To begin construction of the cannon, we first took our 2 tennis ball cans and decided what parts we would use for the cannon base and what parts we would use for the barrel. We cut one of our tennis ball cans to make our cannon barrel, and then used the other tennis ball can to make the stand of the cannon barrel and the net from which we would construct our cone within the cannon barrel. Before going any further, we made a couple of modifications to our cannon design as we thought they would yield us a farther distance. The changes we made included increasing the height of the base from 3.5 inches to 4 inches and decreasing the length of the barrel from 7 inches to 6.5 inches. We decided to keep our angle at 45 degrees.
One of the most difficult parts of constructing our cannon was the creation of the inner core within our cannon barrel. After obtaining our cylinder that we would use to create the cone, we then cut down the length of the barrel to produce a rectangular net and then bent the plastic to create a cone with a bottom base with a diameter of 3 inches and a top base with a diameter of 2 inches. After creating our cone structure that we would use to increase the pressure associated with the firing of the cannon using the properties of osmotic pressure, we then cut the 4-inch tall tennis ball can piece along its side so that when the barrel of the cannon will be placed in it, it will fire at an angle of approximately 45 degrees.
The reason for the base change is so that our projectile might be launched slightly higher in the air and therefore travel a farther distance. We were able to do this by having slightly more material for the cannon base than we needed. We decreased the length of the barrel in order to decrease the volume associated with the combustion reaction and, using Boyle's law, therefore increase the pressure associated with the reaction. Additionally, we used additional material from the tennis ball can to reinforce the outside of the cannon barrel and improve its rigidity, giving the cannon less of an ability to expand when the combustion reaction occurs.
After doing so, we then used one of the tennis ball can lids to create the piece we would use as the top of our cone structure, giving the lid staggered holes from which the air would be forced to rush through, and using properties of osmotic pressure to increase the overall pressure associated with the combustion reaction occurring, attempting to launch our Nerf ball a farther distance. This was a major way in which we factored our knowledge of gas laws into our design. Additionally, using Boyle's law and the inverse relationship between pressure and volume, part of the thinking behind our cone structure was that the decreased volume in the cone as compared to the larger, wider cylinder would inversely cause the pressure associated with the combustion reaction to increase.
One factor we had to consider was that in decreasing the volume and increasing the pressure associated with the combustion reaction, is that in doing so, we also decrease the temperature associated with the combustion reaction according to Charles' law, the combined gas law, and the ideal gas law, which theoretically might mean that our combustion reaction might be less potent and therefore not launch the Nerf ball as far. So considering that, we had to find a happy medium so as not to lower the volume so drastically that the temperature associated with the reaction would not decrease greatly, which is part of the reason why we chose to bend our cone structure only enough to create a bottom surface 3 inches in diameter and a top surface 2 inches in diameter, although there really is no bottom surface. We put together our cannon with very few errors, and hopefully the combustion reaction will proceed as planned and launch our Nerf ball a very long distance. At the same time, increasing the pressure associated with the combustion reaction would also increase its temperature according to Gay-Lussac's law. So the effects of increasing the pressure and decreasing the volume would hopefully cancel out and not affect the temperature associated with the combustion reaction greatly. We are ready to fire our cannon.
Let me rap to you, baby.